Okay, one of the topics that are that is learned in Algebra 1 is you have a unit on polynomials. All Algebra 1 classes have a polynomials unit, and basically, um, I've already in another video described what polynomials are. We have a trinomial here, because that's three terms, it's a trinomial, and a binomial right here. This trinomial has a degree of 2, and this binomial has a degree of 1 because the highest power of x in that polynomial is 1. But something you learn to do, you learn to perform operations with polynomials. So um, we've got, um, we could take these two polynomials and add them, and that's basically just a matter of combining like terms. You've got the 3x squared is the only term with x squared in it, so we have 3x squared. We have a minus x, a plus x, that would cancel out, so I could put plus 0x if I want to. Then in the negative 10 plus the negative 2, that would give us negative 12. We'd simplify that to 3x squared minus 12. Okay, suppose we want to subtract. Well, subtraction, well, that's pretty easy. We would just subtract the like terms, basically. You can't subtract the x from the 3x squared. You can subtract that x from the minus x there. So the simplest thing to do for most people is subtract the x, and we're subtracting the negative 2, which basically turns it into plus 2. So 3x squared, negative x minus 2x minus 10 and plus 2, that's minus 8. So that will be the difference. Well, we can also multiply them. And when we multiply them, we use this notation. We just scoot them over together like this because parentheses in algebra mean multiplication. So now they're multiplying. So here we've got to have a lot of terms, and I'm not going to actually go through this because but you to multiply the 3x squared times the x, and then the 3x squared times the minus 2, and then the negative x times the x, and the negative x times the minus 2, and the negative 10 times the x, and the negative 10 times the minus 2, and you get 6 terms, and some of them would combine. You'd have 3x squared, a whole bunch of other stuff, and the last term would be negative 10 times negative 2 plus 20, and you have some stuff there in between. That's multiplying. But something that is not typically learned until Algebra 2 is how do you divide polynomials? We can divide 3x squared minus x minus 10 by x plus 2. It's kind of neat because it works the same exact way that long division works that you learn in elementary school. The polynomial that we're dividing, 3x squared minus x minus 10, we do this like we're long division, and we put the polynomial we're dividing by on the outside, and we divide. Now, here's how. It's kind of weird. You don't need to pay attention to the minus 2 here. You only need to pay attention to the x. You ask, what does you have to multiply x by to get 3x squared? X times what equals 3x squared? X times what equals 3x squared? X times 3x, I believe. Oh, yeah, 3x. So 3x. It's kind of like long division that you learn with numbers. And then, if you recall the long division algorithm that you learn with numbers, you take this guy and you multiply it by the divisor. So 3x times x minus 2. Well, 3x times x minus 2, you do that using the distributive property. 3x times x is 3x squared. And then 3x times minus 2 would be minus 6x. So you write that, 3x squared minus 6x. And then, what do you do in the long division algorithm with numbers? You subtract this. Now, here's where you have to be really careful. 3x squared minus 3x squared is nothing. You should get 0 to begin with because those should cancel out. Otherwise, this isn't correct because the question we asked originally was, what do you have to multiply x by to get 3x squared? Well, if 3x is right, then 3x times that x better equal the 3x squared. And so when we subtract, that cancels out. But now we're subtracting here, not adding. Most students will be tempted to write negative 7x there, but that's addition. It's not negative x and negative 6x. It's negative x minus negative 6x. So negative x minus negative 6x, negative x minus negative 6x is actually negative x plus 6x, which is positive 5x. So we get 5x here, and then negative 10 minus 0, which is kind of like bringing down the long division of numbers. Now we ask ourselves, what do you have to multiply x by to get this 5x? X times what equals 5x? Well, that should be fairly obviously 5. 5 times x. 5 times that x equals 5x. And now we multiply 5 times the x minus 2. We use distributive property again. 5 times the x gives us 5x. And 5 times negative 2 minus 10. And look at that. We've got a remainder of 0, which means it divided evenly. So that tells us that this 3x squared minus x minus 10 divided by x minus 2 equals 3x plus 5. Now, how do you check division? Well, if this inside divided by that outside equals this quotient, we should be able to check it by multiplying our answer by what we were dividing by. The 3x plus 5, if we multiply that by what we divided by, x minus 2, it should come out to equal what we were dividing. Because you turn division around by multiplying. Well, let's see. 3x times x, 3x squared, 3x times negative 2, minus 6x, 5 times x plus 5x, 5 times minus 2 minus 10, and minus 6x plus 5x combines to negative x. So we have 3x squared minus x minus 10. And so that is how you divide polynomials. Now, sometimes the remainder isn't 0. So I'm going to just kind of make one up that will hopefully not have a remainder of 0. Let's say we have 2x cubed plus 3x squared minus 5x plus 1. And we want to divide that by x plus 2. Now I know this is not going to have a remainder. This is going to have a remainder somehow. So we take this first polynomial, x plus 2 is what we're dividing by. X times what equals 2x squared? Well, x times x squared is, I asked that wrong. X times what equals x cubed? The answer is x squared. Again, we're asking ourselves, x times what equals 2x cubed? Color coordinate that question mark. What do you have to multiply x by to get 2x cubed? Well, the answer is 2x squared. X times 2x squared is 2x cubed. So 2x squared is the first part of our quotient, and then we multiply the 2x squared by the x plus 2. We'll get 2x cubed, and then 2x squared times 2 is 4x squared. And then we subtract, just like the long division algorithm for numbers. 2x cubed minus 2x cubed, they cancel out. 3x squared minus 4x squared is negative x squared. Now we've got to ask ourselves, x times what equals negative x squared? X times what equals negative x squared? X times x equals x squared. So x times negative x will be negative x squared. So it's a negative x. Negative x times x plus 2. Negative x times x is negative x squared. Negative x times 2 is negative 2x. Oh, I forgot a step. We need to bring down our minus 5x plus 1, just like in the long division algorithm. So now we're subtracting again. So subtracting all of this, negative x squared minus negative x squared, again, it should cancel out. Negative 5x minus negative 2x. Negative 5x minus negative 2x. Subtracting a negative is the same as adding. So negative 5x plus 2x, which is negative 3x. And then we bring down plus 1. And finally, we ask ourselves, x times what equals negative 3x? X times what equals negative 3x? Well, x times negative 3 equals negative 3x. So there's a negative 3. So minus 3, multiply, minus 3 times x plus 2, minus 3x, minus 3 times 2, minus 6. And we subtract again. Those cancel out because anything minus itself equals 0. 1 minus negative 6 is the same as 1 plus 6, which is 7. So now the big question becomes, what do you do with this remainder? Well, to answer that, let's look at a simple 23 divided by 5. Well, 5 goes in 23 how many times? 4 times completely. That gives us 20. We subtract the 20, we get 3. Remainder of 3. Does that mean 4.3? Does that mean, what does that mean? Well, it's 4 and 3 out of another whole 5. Look at it this way. 23 divided by 5 could also be written this way. 23 divided by 5. The 4 is 20 divided by 5. And we have 3/5 more than that. So it's 4 and 3/5. This 3 remainder is the numerator of the divisor for another, is that part of another whole, 3/5 of another whole. So in the polynomial division, we take that remainder 7 plus 7x plus 2. That's not really something to say. 7 over x plus 2. And that is the quotient. Fun times. Have fun with polynomial division. Everybody loves it. That's not really true.